Welcome all. Welcome back again to the lecture series of Astronomy and Astrophysics. My name is S.G.PARKHE and I am working as an assistant professor in KTHM College, Nasik. So in the previous lecture, we have seen that the solar system and the nebular theory, which explain the formation of stars and planet. According to this theory, there is a big molecular gas cloud and which is spread over the interstellar area, and due to self-gravity the molecular gas cloud contract and it acquired angular momentum and it became more denser, and due to the conservation of angular momentum the molecular gas cloud turns into disc shape and rotates anti-clockwise direction. So due to the nuclear fusion reaction takes place at its center and the protostar is formed at its center, and the remaining all matters rotates, collapses on each other, and the planetary disk shape is formed around the protostar, and the gaseous planetary shape or the gaseous planetary disk evolved the planets. So this is the nebular theory which explains the solar system. So in solar system, sun is the center of our solar system. So near about 500 years ago, people thought that Earth was the center of our solar system and remaining all the planets including sun revolve around the Earth. But by the time Johannes Kepler was born in 1571, and people were starting to get the idea that sun is the center of our solar system and all the planets including Earth revolve around the sun. And Kepler was the first who explained the movement of the planets, and the orbits around the sun is not a perfect circle but ellipses. So as we all familiar about our solar system, sun is the center of our solar system and there are 8 planets revolve around the sun. The first 4 closest planets are terrestrial planets or rocky planets, and then asteroid belt. The first planet is Mercury, Venus, Earth and Mars, and then one asteroid belt, and then after that 2 gaseous planets, Jupiter and Saturn, and 2 icy planets, Uranus and Neptune, and at the end there is a Kuiper belt. So this is the structure of our solar system. So in the starting 1801, the astronomers discovered Ceres and other bodies in between Mars and Jupiter and were considered to be a planets. And around 1851, the number of planets reached 23. Then the astronomers started using the word asteroids for the smaller object and stopped naming them as a planet. In 1930, most of the astronomers thought that the solar systems to have 9 planets and thousands of bodies, and I am talking about Pluto. And almost 50 years, Pluto was thought to be larger than Mercury. But with the discovery of Pluto's moon, Charon, in 1978, they determined the mass of Pluto, which is much smaller than the initial estimate, and it was roughly around 1/20th mass of Mercury. And then the astronomers stopped referring the Pluto as the planet, and also having some unusual characteristics like orbital eccentricity, orbital inclination, means all the planets are revolved or orbiting in the same plane, but Pluto is orbiting in inclined plane. So it becomes an evidence that the Pluto is different kind of object or body from any other planets. Then in 1990, astronomers begin to find out the object in the same region of the space as Pluto, and Pluto started to being seen as the largest member of new class of the object and named as Plutinos. And then astronomers stopped referring Pluto as the planets. So this is the whole history of our solar system. Then the next point is very important for solar system, astronomical unit. astronomical units of distance. Let me draw a scale here. 10 raised to minus 35 meter, 10 raised to minus 5 meter, and 10 raised to 25 meter. So this 10 raised to minus 35 is the smallest scale in the universe up to which we can go, and it is also known as Planck's scale. Ten raised to 5 minus 5 meter, as we all familiar about it, life, size of the cells of living organism, cells of our bodies. And 10 raised to 25 meter, this is known as Hubble scale. This is the scale, this is the largest scale up to which we can go, or which we can see, the Hubble scale. The Hubble scale is much larger than the speed of light, or we can say that the light travel the distance in 1 year. The Hubble scale is much larger than that, because the space itself expands much faster than the speed of light. Anyways, so the units of the distances, one is light year, second astronomical unit, or we can say that AU, and third one parsec, or it is also called as PC. These are the units of the distances in space, or astronomical units also we can say that. So let's see what is light year exactly. So light year, it is, the short form is L by. So light year is the average distance, or we can say that light travel the distance in 1 year, because we know that the speed of light c is equal to 3 into 10 raised to 8 meter per second, means this much distance travel light in 1 second. And the interesting thing is that light takes 8 minutes, light takes 8 minutes and 20 seconds to reach the earth from the sun, and it will take 4.2 years from 4.2 years from the nearest star, Proxima Centauri. Nearest star, and it will take near about 2.5 million years from the nearest largest galaxy. All right, so 1 light year, so we know that 1 year is equal to 365.25 days. This 0.25 is because of leap year. Therefore, 365 into 24 into 60 into 60. So 1 year having near about 3.156 into 10 raised to 7 seconds. So light travel in 1 year is 1 light year is equal to 3 into 10 raised to 8 into 3.156 into 10 raised to 7, and the answer is here the unit meter per second and here second. So second get cancelled, only the meter is the unit for that, and it is around 9.47 into 10 raised to 15 meter. So 1 light year is equal to 9.47 into 10 raised to 15 meter. Alright. So I hope you can calculate 1 light second, 1 light minute, 1 light hour, 1 light day, and so on. Just calculate at home. Now the next is astronomical unit. Let me write here. Astronomical unit. This is also the unit of distance. Astronomical unit is nothing but the average distance from the sun to earth or earth to sun. So here the distance between earth and sun, it changes with respect to time. Its minimum value is around 1.47 into 10 raised to 11 meter in January, and its maximum value is 1.53 into 10 raised to 11 meter in July. Yes. Then the average distance, average value is nothing but 1.50 or 1.5 into 10 raised to 11 meter. So therefore 1 astronomical unit is equal to 1.5 into 10 raised to 11 meter. This is the distance of earth to sun, 1 astronomical unit, or we can say that 1.5 into 10 raised to 11 meters. Fine. Now the third one is very important, parsec. Or we can say that PC. Parsec is also the unit of distance. It is the length so that 2 points are separated by the distance 1 astronomical unit, and the angle suspends 1 arc second. For example, suppose it is the length here, this is the point O here, and 2 points, let's say A and B, are separated by the distance 1 AU, right? So this distance is nothing but 1 PC, and the angle suspended it by 1 arc second. One arc second. This angle must be in radian while you are measuring or determining the distance, right? So we know that the condition is 1 degree is equal to 60 arc minute. So let's convert it into radian. So we know that 360 degree is nothing but 2 pi radian. So 1 degree equal to 2 pi upon 360 radian, or we can write 1 degree equal to pi upon 180 radian, right? And we know that 1 degree is equal to 60 arc minute. So therefore 1 arc minute equal to pi upon 180 into 1 by 60 radian. Similarly, 1 arc second equal to pi upon 180 into 1 upon 60 into 1 upon 60 radian. And this value is near about 4.848 into 10 raised to minus 6 radian, 1 arc second. So therefore, now here these are the 2 points which are separated by 1 astronomical unit, and we know that by angle in radian. So if we consider this OA as a radius, and if we draw the circle, then we will get the arc here, and this arc of the circle, which is nearly equal to the distance separated by 2 points, because this distance is so far, right? So if OA is very greater than AB, then the arc length, let's say L be the arc length, so L is nearly equal to AB. Then we know that the angle is equal to arc length upon radius. If you consider this is as a radius, and if you draw the circle, this is the arc length. So arc length is nothing but AB, and which is equal to 1 astronomical unit upon radius is nothing but 1 PC, and this is the angle theta, or 1 arc second here. So we can calculate 1 PC, and which is equal to, if you put the values of theta here and 1 astronomical unit value, so we can find out 1 PC, and which is nearly equal to 3.09 into 10 raised to 16, yes, into 10 raised to 16 meter. So these are the 3 astronomical unit of the distances, which is very important, right? I hope it is clear. Now the very important in the universe, the objects are so far away from each other. So in the beginning, Johannes Kepler, he just figured out how much closer or further all the planets to the sun than the earth, because he just knew that the Mars is closer than Saturn, because Mars orbits takes 2 years and Saturn's orbits takes 29 years. So he just figured out that Mars is 1.5 times further away from the sun than the earth, and Saturn is 10 times further from the sun than the earth. But one of the best scientists who discovered the parallax method, and the name of that scientist is parallax method. This method is used to make the measurements of the distances to the planets. Giannis Cassini in 1672, parallax method. So you can understand the parallax by holding your thumb up at your arm's length, and if you are looking at it by your one eye and then with the others, with your other, and it's because you will notice that this thumb seems to shift back. If you observe by your one eye and then with the others, then you will notice that the thumb shift back, and it is because your two eyes are separated by few inches, and each one views your thumb in a different position. So the appearance of any object in a different position from the different views, this is known as the parallax of that object. I hope it is clear. So this parallax method, which explained by Gian Cassini in 1672, and with the help of this parallax method we can determine the distances of any object which is far away from our earth, right? So first consider the earth's surface here, and if you consider an object over here, planet here, planet, and this is the earth's surface. So if you consider, let us consider two observatory here, A and B, and separated by the well known distance, separated by, let's say, B is the distance between two observatory. If we observe the planet from the point A, so this will be the line of sight, and if you observe it from point B, let's say capital D is the distance between the planets and the earth's surface, then it makes an angle theta. If you observe it by two observatory, and similarly if we consider this D as a radius, and if we draw a circle, then we will get the arc length here. Let's say arc length is L, and since this D is much larger than the B, therefore this B equal to L, which is nearly equal to L. So similarly, again angle equal to arc upon radius. So arc is nothing but B, which is the distances between two observatory on the earth's surface, and radius is nothing but D. So this is the angle theta. This angle theta must be in radian, and we know that how to convert degree to radian, right? So this D we can calculate V by theta if we know the theta. So this is the simple formula by which we can determine the distance of any planet or object from the earth. Similarly, this is the step 1. Similarly, if you want to determine the diameter of the planet, same planet if we have here, and if you want to find out the diameter D here, let's take one observatory now and observe by one observatory A. If this is the distance D which we determine here, and D, small d, is the diameter of that planet which we observe from the earth's surface, and it makes an angle, let's say phi. Therefore again, if we draw the circle, this is your arc length, and which is nearly equal to the diameter because this distance is so far. Therefore again angle equal to arc upon radius, and which is equal to D, this arc length which is nearly equal to the diameter of that planet, and radius is D, and this is the angle phi. If you want to find out D here, just take this term in this side, so phi into capital D. So this is the another formula by which we can find out the diameter of the same planet from the Earth. So this is the parallax method which is used to measure the distances and the diameter of the planet or object which is far away from the Earth's surface. Now the very important let's draw the solar system structure. So this is the Sun, as we all familiar, and these are the 4 orbits which are closely packed, and this is also known as the inner planets, terrestrial planets. This is the Sun which is at the center. This is the Mercury, Venus, Earth and Mars. Then very important, there is asteroid belt. And two gaseous planets, Jupiter and Saturn. And 2 icy planets, Uranus and Neptune. And then after that, the Kuiper belt, which is much larger than asteroid belt, and the Pluto is here somewhere in Kuiper belt. So this is the structure of our solar system. And one more very interesting member of our solar system I am going to introduce, that is here, Halley's comet. Which comes after 76 years every time. Last it was appeared in 1986, and the next it will appear in 2061. That time maybe you will be the retired person, but you can see this Halley's comet in 2016, and I am sure that I won't be here that time, maybe in the other universe. But and the one very lucky thing is that our Earth is orbiting in a very proper channel, because if we are few lakh kilometer inside, then we are burned to death, and if few lakh kilometer we are outside, then we die of cold. So I must say that the life on the Earth is just an accident and not miracles. So I hope this is the whole solar system.
Sun. It is a nearly perfect sphere of hot plasma. Plasma is one kind of state of matter like gases in which atoms have been ionized and the electrons ripped away from the atom. And this plasma is due to the nuclear fusion reaction occurs at the center of the core. The Sun accounts 99.86% of the total mass of the solar system, and 3/4 of Sun's mass consists of hydrogen. It's nearly 73%, and the rest is mostly helium, 25%, and the remaining for the heavier element like oxygen, carbon, neon, and iron. And Sun fuses about 600 million tons of hydrogen into helium in every second. The mass of the Sun is 1.989 into 10 raised to 30 kg, and its age is about 4.603 billion years. Mercury is the smallest and innermost planet in our solar system, and it takes 87.97 Earth days to complete an orbit around the Sun. Mercury consists of 70% metallic and 30% silicate material, and its density is the second highest in our solar system and slightly less than the Earth's density. Its diameter is 4,879.4 km, and the distance from the Sun is 57.91 million km. Venus is the second planet from the Sun and the second brightest natural object in the night sky after the Moon. It consists of more than 96% carbon dioxide, and it has the hottest surface, and it is roughly around 787 degree Kelvin. And very funny, sometimes it is called as Earth's sister planet because of the similar size, mass, bulk composition, and etc. The mass of the Earth is 5.972 into 10 raised to 24 kg. Its diameter is about 12,742 km, and the distance from the Sun is 149.6 million km, or we can say that 1 astronomical unit. So 1 astronomical unit is equal to 149.6 million km, or around 150 million km. Mars is the fourth planet from the Sun, categorized in terrestrial or rocky planet like Earth. Sometimes it is referred as a red planet. It is due to the effect of iron oxide prevalent on the Mars surface, and which gives the reddish appearance. NASA launched the first spacecraft in 1964 to visit the Mars, and ISRO became the fourth space agency to visit the Mars. Jupiter is the gas giant, and its mass is around 1.898 into 10 raised to 27 kg. Its orbital period is 12 years, and it has 53 number of moons. Saturn is also gas giant. Its mass is around 5.683 into 10 raised to 26 kg, and its orbital period is 29 years. And also it has number of moons 82. The Uranus is the ice giant. Its age is 4.503 billion years, and its orbital period is 84 years. And also it has the closest planetary atmosphere in our solar system. The distance from Sun is 2.87 billion km, and it has 27 number of moons. Neptune is the last planet in our solar system. Its mass is around 1.024 into 10 raised to 26 kg, and its orbital period is 165 years, and the distance from the Sun is 4.495 billion km, and the total number of moons are 14.
So good luck, enjoy. Thank you.